All right, finally we have this last example. It's a little complex. What we want to do is we want to figure out um, how fast you want, how fast you need to run to actually win the race. So again, at t equals 2 seconds, you're 20 feet behind the other, or you're 10 feet, or actually you're 8 feet behind the other guy. You're at minus 20 from the finish line over here, right? And the other guy is minus 12 feet from it. Um, and what we want to do is we want to figure out what you need to do to win. Now, obviously, if 5 feet was enough for you to win at these speeds, we don't really have anything that you have to do. That's not going to be the case. So I'll show you that really quickly. Then we'll do all the work we need to do to figure out the acceleration you need to catch up. We're going to assume it's a uniform acceleration to make things easier. All right, so first, the time for the leader to win. What do we need to do to find that? All right, so we're going to go back to what we were doing previously. We were using our definition of the average velocity, which is delta x over delta t. Here, the delta x is, the x final is 0 feet, minus your initial position, which is minus 12 feet, over the duration, which is the thing we want to find. And v bar, if we assume that the leader doesn't speed up, is 4 feet per second. Okay, so we'll go with that 4 feet per second. How do we do this? Well, what we're going to have to do is we're going to have to multiply both sides by delta t over 4 feet per second. And that will get us delta t on one side and 4 feet per second on the other. So we want delta t on one side. Then we 0 minus 12 feet. Minus 12 feet is positive 12 feet. Over this 4 feet per second. And that's just 3 seconds. So it's going to take this guy 3 seconds to win. For you, how long would it take? Well, now you've got the 20 feet to run at 5 feet per second. So 20 over 5, that's 4 seconds. So you're not going to get to the finish line until a second after he gets there. So you're going to have to speed up. So let's see what sort of things we can say about catching up. The first thing is the average speed to catch up. So again, this is going to be the same thing we did previously. V bar is equal to delta x over delta t. The delta x is the 20 feet we were just talking about. Delta t is now the speed for the other guy to get there, not the speed that you're going to get there in that 20 feet. So what we're going to have to do is we're going to have to use 3 seconds. So that's going to tell us the average speed over the time interval, or over this distance, this 20-foot distance you'd have to run to beat this guy going 4 feet per second who's 20 feet from the finish line. And we just do that division, right? And that's going to be 20 over 3. That's 18. 3 goes into 18 6 times, and you have 2 left over. That's 6 2/3 feet per second. Although we might want to just leave it in 20 thirds feet per second, because we're going to do more algebra work later on. Okay, so that gets us the average speed you need to catch up. But to just decide that whether or not this is even possible, right, we need to figure out what your speed is at the end. So you're going to accelerate over that entire interval. You're going to get faster and faster and faster. If you end up having to go 70 miles an hour, you're probably not going to be winning the race, right? Because you're not going to be able to accelerate to going 70 miles an hour, right? That's just impossible. So let's see what we can do here with this final speed. For that, we use our other definition of the average velocity when your acceleration is uniform. That's v bar is equal to final plus initial over 2. Okay, so our v bar is equal to your final velocity, which is vf, plus your initial velocity, which is this 20 feet, or no, that's 5 feet per second, That's divided by 2. That 23rd is the v bar, so that 23rd feet per second over here. V bar is equal to 23rd feet per second, as well as equal to this thing. All right, so let's multiply both sides by 2, so we have Vf is equal to 5 feet per second. Or plus or minus plus 5 feet per second equals 40 thirds feet per second. We might want to multiply this by 3, or get this in thirds so we can add it. So it's 5 is 15 thirds, right? 5 equals 3 times 5 over 3, which is equal to 15 thirds. So we have 15 thirds feet per second. So Vf is going to be equal to this 40 thirds feet per second minus, it's plus over here, it's minus over there, 15 thirds feet per second. And so that's 25 thirds feet per second, which is approximately 8 1/3 feet per second. And that's going to be really fast. I don't think you're running that fast over that period. I think that's more or less about 16 miles an hour. But that's just my guess. So that's really fast. Maybe you can do it. Maybe you're a lot fast. You're definitely a lot faster than me. I'm 50 and you're 20. So the question is now, what acceleration do you need to do that? Right. That also may be impossible. I'm not completely sure. I don't have any idea about how fast a human being can accelerate. All right. So how we do that? Well, we use our definition of acceleration, delta v over delta t. So we have to go from or to this 25 thirds feet per second from 15 thirds feet per second. And we're going to do that in 3 seconds. Okay, so that's 10 thirds feet per second in 3 seconds, which is 10/9 feet per second squared, which is 1.11 feet per second squared. I don't know, but I think that's doable if you can actually do it with your legs. Because you do have to worry, in the real world, you have to worry about things like air resistance, but that's probably doable. 1.11 feet per second squared. And this part was off. Okay, so I didn't correct that part. That's why things seem so strange. Okay, so, all right, we're doing okay. What actually happened here? So, to find the acceleration that you need to catch up, you need to figure out, one, the time it takes to get, or the time it's going to take to, for the person you need to catch to get to the place where you need to catch him by, in this case the finish line and the leader. That's part A. And here we just did what we did last time with the average velocity. Then we need to figure out what your average speed to catch up would have to be. Using the definition of velocity again, we need 20 feet in this time, right? Remember, it would take you 4 seconds to get there, so you have to speed up over those 3 seconds. That average velocity would be 6 2/3 feet per second. The final speed for the tie you get from the uniform acceleration condition, which is that the average velocity is the average of the initial and the final velocities. So that gives you the 6 2/3 feet per second. Or that's equal, that doesn't give you that. So then we do our math in here, and that gives us 8 1/3 feet per second. Then we have to do our acceleration to catch up. Here we use the definition of acceleration. Issue here is that these guys happen to be wrong. So that made life a little bit harder. So ignore the part that's wrong. Just that. So we'll just kind of do that again really quickly. Unfortunately, it's not as pretty. If I can actually get the thing to come up. I don't know why sometimes it doesn't come up. Okay, so let's do it in a nice bright color so it makes sense. So here we need VF, which is that 25 thirds feet per second minus your initial speed, which is this guy, which is 15 thirds feet per second. We're doing that in 3 seconds. So 25 minus 15 is 10. 3 times 3 is 9. So that's feet per second squared, right? Which is 1.11 feet per second squared. So we used in this VF that we found here and this delta T that we found here. To get VF, we had to use the average velocity that we got from B. So that's the reason for having all of those 4 things. But we've seen that even in this complex problem, repeated use of different things will get you what you need to get. All right. Okay, that's enough for this week. Let's get to something else next week. Next week we'll do some vectors and turning and centripetal acceleration and all that other fun stuff. All right. Talk to you later. Bye now.